let's focus on determining domain and range of the following relations here. Um, and then stating if something is a function or not, and then we have to give some justification, okay? The main rule for if something is a function has to do with every x coordinate has one y coordinate. So every x has one y. If there's more than one y to any x, then we know something's not a function. So we'll kind of keep this rule here in mind as we look through some of these things, okay? So we could probably jump through quite a few of these. This one here, what you can do when you have sets, so this is a number set here, and they have coordinates, so there's two variables or two dimensions to this set of numbers. They have probably what's represented as an x and a y. Since every y is the independent, there has to be one y for every x. So one of the first things we're going to want to go through is to quickly decide if something is a function. We can just quickly look at all of the x values and see if there's more than one of them written anywhere. So I look for ones, and it looks like there's no other ones. The number 3 doesn't appear. 5 doesn't seem to appear. 0, -1, 6, and 10. They all seem like they're individual. So what that means is there's a distinct y value for each one. So we can actually give this a check mark, and we'll say this is going to be a function. To set up the domain of this, we can just say domain is, and then we just set the list of the numbers. We use these kind of curly brackets, and we just list all the x values for the domain. So 1, 3, 5, 0, -1, 6, and 10. Usually they'll want you to put it in order from maybe least to greatest. Technically this is a complete set, but if they want it to be a specific way, we would set with -1, 0, 1, 3, 5, 6, and 10. Okay, so that's the domain. And then the range of this question, very similar. We don't have to check anything for the range part because we already checked off the domains. So for the range, we just got to check out what all the y coordinates or the second coordinate, the dependent variable, is here. If a number occurs more than once, we don't have to write it more than once in the range or domain. We can just write it one time. So we'll list them out here and then we'll rearrange. So we have 2, 4, 3, 0. 2 shows up again. We'll write it in a third time, and then -10. So this wouldn't be a complete set because, or not a correctly written set because we have the number 2 written so many times. So what we'll do over here is we'll rearrange it so that it's in order. So we have 0. We only have to write the number 2 once, so we've kind of crossed that one off. Whoops. 2, 2, 2. Got rid of 0. 3, 4. Oh shoot! And then -10. We'll kind of squeeze it in there before. That is our range for this question. Okay. We would duplicate that same process on question B. What we'll do is we'll just jump to another one that has a different looking interface. So this one, they've set up 2 ovals to represent sets. So think of this as like the x coordinates of the set, and this one here are the y coordinates of the set. Okay, so this is already set up. Our domain, we know are 1, 2, and 3. Very simple to write out. And our range for that one are -12. I have to write it below here. -12, -5, 0, and 4. What's important is to check, is this a function? So we look down here, this one only has one y coordinate, so that checks out. This 2 has only one coordinate, y coordinate, that checks out. This 1 actually has 2 y coordinates, so that doesn't check out. That means that this is not a function, C, because it does not abide by that rule we've written here, okay? We're going to jump over to H here. Since D is similar to above, E we've looked at before. Let's take a look at H. This is the other way they might represent a question like this, okay? This one has a couple of distinct features to it. There is a hollow circle on the left-hand side and a full circle on the right-hand side. And this is also continuous, okay? So we're not going to write specific numbers for it because there's an infinite number of numbers to write. We can't write that many numbers. So what we do is we represent the range a different way. In this case, we're going to say the domain is the x is the element of all real numbers. So all real numbers representing all decimal values, anything in between. And then we draw a vertical line to say such that. Now, this coordinate here looks like it's at, I drew over it, sorry, is at -7 is the x value, and this one's at +7. Great. I'm going to write this in. I'll write x in the middle, I'll write -7 and then +7. Now, x is definitely greater than -7 and less than 7, but the only other part we got to write has to do with this hollow and the filled in circle. The hollow circle means it doesn't actually touch -7. So we wouldn't put a equal sign. We wouldn't say less than and equal to. We would only say less than. But here we have a filled in circle. This represents it also touches the value of 7. So here we would say x is less than and equal to 7. So that would be the domain of that. The range is a little trickier. It looks like it goes from +7 to -6. Same idea with the range. Because it's continuous, we'll say y is the element of all real numbers such that, and we could write y in the middle, and we'll put our lowest value to the left, so the lowest value happens to be -6. Our largest value happens to be +7. Y is in between the two of them, so we say -6 is less than y and y is less than 7. End it with our curly brackets, and we just got to figure out, does it touch? We know down here it's a filled in circle, so we know that it's also equal to 7. This part's a little trickier. We have to visually take a guess at it. I would think, oh sorry, that should have been here at -6. I would think that it is touching 7. So we're going to say that y is greater than and equal to -6, but less than and equal to 7 for the range. Okay. So we've gone through many different interfaces of how to look for domain and range and tell if something is a function.